things like integration, API management, analytics. And it's something that's been hitting every single industry that we've been seeing. And so we're especially excited to have our guest speakers here today to talk about how this has been transforming the energy industry. And if you like this event and want to be participating in more of these, I just wanted to mention that we have another one coming up in a couple weeks, Fast Data Analytics with TIBCO, Spotfire, and MATLAB. So we're going to be talking about our analytics tool in conjunction with the folks at MathWorks and using the MATLAB product. So if you like analytics, want to see more of these kind of events, please sign up on our meetup page. Thanks.
Beautiful. Thank you so much, TIBCO, and good evening, everyone. On behalf of the Hive, if tweeting, please just go with the Hive data tonight. The Hive Think Tank is a forum for thought leadership. We focus on two things. One is all things data, and another one is entrepreneurship. We had amazing speakers on the Hive stage. These are just a few of them. Since our inception, we organized over 150 events. Tonight's event is the 16th event this year. So I don't know if you know, but on average we organize around 3 events per month. We are really happy that our community is growing. We have over 8,000 data-driven innovators in our community. Thank you to all of you who are here with us for the first time. And to all of you, I see many familiar faces coming again and again to our events. Next event is only 6 days away. It's taking place on the 7th, on Tuesday. It's a panel discussion on digital factories, disruptive opportunities for startups, with 5 VC representatives from GE Digital, Sapphire Ventures, ABB, Siemens, and SAP. You can register if you haven't done it yet on our meetup page, the Hive Think Tank, for this event as well. Without our sponsors and our partners, many of the Hive Think Tank events wouldn't have happened. So we'd like to give a big shout out to all of them. The Hive Think Tank events are brought to you by The Hive. More about The Hive from Managing Director and the co-founder of The Hive, T.M. Ravi.
Thank you. Thank you all for coming today, and we're excited to have TIBCO hosting this event. How many of you were here when Pinterest, Yuri Leskovec spoke? Cool, so that was a great event too. So just a brief overview of the Hive. So Hive is a venture fund, but it's a venture fund with a difference. The main difference is that we are a studio that creates companies. And so we get involved with entrepreneurs at a very early stage. And we do 4 to 5 companies a year and kind of take them to the next level. Typically spend a year and a half with them. The other unique aspect of the Hive is everything we do is related to AI and big data across 3 different segments, enterprise, online, and IoT. And we have a few themes that we focus on. And so if any of you are interested, just reach out to me or to Sasha. Some of our companies are hiring, so if you're interested, just reach out to me. Neva is an autonomous agent that automates the service desk and support desk. And Sensify is an IoT security company that leverages blockchain. Be a part of the conversation today. If you can use the hashtag HiveData, it would be awesome. So the way we'll structure today's conversation is, today's talk is, Prith will give us a talk, and then we'll have ample time afterwards for Q&A. And so, Sasha's got to be the control. So I'm honored to have Prith Banerjee here as the speaker today. Prith is EVP and CTO of Schneider Electric. Schneider is a global leader in energy management. I had the great fortune of being at their Grenoble office maybe about 3-4 weeks ago, and just jazzed with their vision of the future, which affects each and every one of us. Prior to that, we got to really know Prith when he ran kind of global R&D and technology at Accenture, based here in San Jose. And prior to that, he had a very similar position to what he has now with ABB, I guess a Swiss company, in sort of similar sort of area. And many of us here in Silicon Valley know Prith from his days at HP Labs, where he was the head of HP Labs and kind of the EVP of R&D. And so Prith comes to industry, he has been an entrepreneur. Before that, a distinguished faculty member in a number of universities, including University of Illinois Champaign-Urbana, where I happen to be born. So with that, I'd like to welcome Prith Banerjee.
Thank you very much. It's an absolute pleasure to be here today. Thank you all for coming. I know it's evening time. I appreciate your coming. Thanks, Ravi, for the invitation. Thanks to TIPCO for hosting it. It's a fantastic place. I have known of TIPCO a lot during my days at Accenture, but I never had a chance to visit your offices. Fantastic place. So what I'm going to talk about today is a topic that I'm sure you are kind of sick of hearing about IoT. Everybody talks about IoT. There's like literally hundreds of platforms out there. Every company has an IoT platform and so on. So it's kind of, this area has been beaten to death. What I will do is, rather than talk about, oh, here is one more IoT platform, of course we do have an IoT platform, but focus the conversation in a particular industry, the energy industry, which I think is one of the biggest opportunities. If you look at sort of the impact to society, it really has tremendous potential, and IoT can actually make a big difference in that area. So it's the talk on IoT, innovations in IoT at all levels, but specifically focused on the energy sector, because that's what Schneider is all about. Now, as Ravi mentioned, I have had the pleasure of working with sort of 4 very distinguished companies. 2 in the IT sector, HP and Accenture, and actually started working on the IoT area when I was at HP Labs. We had a project called SENSE, which was Central Nervous System for the Earth. The vision was connecting up sort of millions and billions of stuff and doing analytics on it. And so of course that was a little ahead of its time, but that's where I first learned and got excited about the world of IoT. Then when I went to ABB, which is now a competitor of Schneider, I was literally recruited to ABB. I asked the CEO, I said, well, why are you hiring me? I don't know anything about energy management, breakers and so on. He said, well, we would like to get into this area of software and IoT, so please help us in defining how IoT can influence ABB and its services business. So I spent a year and a half there, had a lot of fun. So I kind of learned a little bit about IoT and in this energy area. Then came back to the Bay Area to work for Accenture, and that's where I think I made my maximum thought leadership contributions. We did a lot of work, so Ravi knows some of the work. I did work with the World Economic Forum, worked on some interesting thought leaderships about how IoT is enabling sort of products to be connected products and then transform and having services on it and then changing outcomes and so on. So there's a very futuristic, thought leadership kind of stuff presented at Davos. And at Davos, as many of you know, there are sort of CEOs in the audience. And there was the CEO of Schneider Electric who was sitting there. He says, Prith, I would like you to translate that vision into Schneider Electric. That's literally how I got my job, because of speaking of IoT at the World Economic Forum. So anyway, so here I have been at Schneider now for about 9 months. It's an amazing company, and I'm the CTO for the company, which is trying to be responsible for our technology strategy. It's a 27 billion euro company. We invest about 1.3 billion euro on R&D. We have about 11,000 people in R&D across the 4 businesses that I will talk about. So my role is to coordinate all the R&D and so on and so forth. But the one thing that I'm really passionate about is this, right? So everybody at Schneider knows, you ask Prith any question, the answer is IoT. So this is something, it is an absolute pleasure to talk to you on this topic. But what I wanted to kind of set the stage for is sort of Schneider's overall vision, right? What is the mission sort of statement at Schneider Electric? And it's very simple. It's saying that if you think about the core things that society really wants, right? Society needs water, food, and energy. That's it. I mean, you can actually do without Instagramming, you can do without Google searching, you can do it whatever, but you cannot do without food, you cannot do without water, you cannot do without energy. So we believe that having access to energy is what we call a basic human right. And today there are 1 billion people on this planet who do not have access to energy. And there's another billion who have access to intermittent sources of energy. And that is fundamentally wrong. And so our vision at Schneider is what we call life is on. Make sure that energy is available in a safe, reliable, sustainable manner to everyone, everywhere, at every moment. And so all companies have this kind of vision and so on. What I will try to talk about is, there are these 5 bullets here. Safe energy, right? So you can obviously deliver energy in whatever way, right? But when there is an electrical short, the fact that there's a breaker that goes off, right? And it prevents a building from getting burned, that's safety. So you have to have safety as the core, right? Then you need to be reliable, you have to be up all the time and so on. So there are some core attributes when you're in the energy management business: safety, reliability, efficiency, connectedness, and sustainability. And so I'm going to talk about sort of these innovations at all these levels. So my title of my presentation is Translating IoT at All Levels. It is how we are innovating at all these levels in this whole energy area, right? But I'm going to end with this same slide. Life is on, and I'll try to bring it all together. So my first 10 minutes will be on motivating the problem and some of the global trends, because I think it's important for us to all understand the mega trends. So one of the big things that we have noticed is that in the world, right, and if you look at the next sort of 30 years, there is a trend towards urbanization. More people are moving to the cities. You look at China, right? People used to live in rural areas, and they are all going to the cities. And what happens when people move from villages to the cities? The energy consumption goes up. Second thing is digitization. Everything is digital, right? We all have cell phones, this time, tweeting and Instagramming and so on, uploading pictures, whatever, right, etc. And that is generating a lot of energy consumption. And then there's the industrialization, right? As more and more things get industrialized, that is increasing energy consumption by about 50%. So I've looked at some numbers, and it says that in the next sort of 30 to 40 years, the energy consumption in the world will go up by about 50%. 50 to 60 to 70, some big amount. Now, when energy consumption goes up, that's kind of bad things happen in the climate, right? And so there's CO2 emissions and so on. And then all these world leaders came in and they met in Paris and they said, oh, we are going to, we agree, COP21, they said, we will reduce carbon emissions so that the increase in our temperature will be reduced be kept to within 2 degrees Celsius, right? So your energy consumption is going up, CO2 emissions going, you have to reduce it by a factor of 2. So you have to do 3 times more energy efficiency than what is happening today. So this is a real challenge in the energy world. Again, people who are working in energy companies like ABB, Siemens, GE, etc., they know this. So this is sort of a fundamental problem in the energy industry. And then focusing on the specific energy area, there's sort of fourth thing that I want to kind of talk about, and that will then be tied to the area of IoT. The first is that the world is becoming more electric. So all those Tesla cars that I saw in the TIPCO parking lot, right? I mean, you used to drive gasoline cars, now they're all electric cars. And all the things that we had probably one radio in our home, right, 30, 40 years ago. Now we have 10 laptops and 42 iPhones and so on. So the world is getting more electric. In fact, the numbers are, in terms of energy consumption, it is going to increase, but the electric energy consumption will go up twice that of the rest of the energy consumption, right? So it's like it will go up by 80%. Electric energy consumption in the world will go up by 80%. So that's, the world will be more electric. The world will be more digitized, right? All of us know all this, and we have seen all these numbers about connectivity of devices and so on, 50 billion devices, etc., etc. The world will be more decarbonized, right? So all these things that we consume, energy consumption, right, creates CO2, etc. Those things are bad, and therefore you are better off if you could do renewable energy, right? Renewable things that does not generate those carbon fuels, etc. That's kind of a good thing. And one number that I would like to share is that you look at a building like this, you look at the energy efficiency of this building, it is only 18% efficient. There is an opportunity to improve the energy efficiency of this particular average building. I think the TIPCO building is super duper efficient, but the general buildings, you can have opportunity of about 82%. That's a tremendous opportunity. And then finally, the world is getting more decentralized. So as people think about energy generation, right? People are all concerned about the fact the world is getting more electric and say, oh, this is really bad, right? So today morning I gave a talk in the Clean Energy Summit. There's a bunch of 25 energy ministers of the world gathering here in San Francisco, being hosted by Energy Secretary Ernest Moniz. And so all those government leaders are talking about what are we going to do, what are we going to do, right? And the number that I shared in that presentation was that by the next 25 years, by 2040, the world will generate, will produce 435 gigawatts of additional power at that time. Of that, 70% will be renewable, solar, wind, etc., right? Now in the energy area, distribution area, in the past, the energy used to be distributed, sort of generated in a hydroelectric plant, or a nuclear plant, or say a coal plant or whatever, right? Centralized generation, and then you had that star network to distribute that energy through those transmission distribution lines and so on. And when the power consumption went up, you turned on one more sort of coal power plant. You turned on a thing, right? So the inertia that you had was much, much longer, right? You had an hour to address the demands. You say, yeah, my demands will go up at 8 p.m. in Palo Alto, and then you turn on your whatever plant. As the world gets more decentralized with all the renewables, right? You have solar power producing energy on top of your roof. You have wind power. The wind goes down, right? Suddenly it stops. They start shade because you have clouds, etc., right? These renewable sources, if it is going to be 70% renewable and it is intermittent, managing this energy grid is a real problem, because in your electrical engineering, you turn on an energy source and then you have to have a load. And the source and the load have to be exactly managed, right? So as you have more and more consumption required, the utility companies were increasing just turning on more and more generators, right? So you need to have a balance of system. If that thing, right, is intermittent, it's a real pain, very difficult to manage this thing. So the world is getting more electric, more digitized, more decarbonized, whatever. Renewable energy, intermittent generation, it is a fantastic problem to solve, very challenging, really hard. And IoT is one of those enablers that is really is actually going to solve that problem. So this is a chart I think you have seen, that the number of it went so fast that I couldn't even see this. So the number of connected people, about 5 billion people. Number of connected things, about 50 billion. So IoT, this number of things, like everything is getting connected. So Schneider makes circuit breakers, panels, UPS devices, etc., etc. All of those things will be connected to the internet, will have an IP address and so on. You're collecting a lot of data, just massive amounts of data. Through these mobility and analytics, you're essentially seeing in the world of energy, right? The combination of energy, this IT-OT integration, or sort of energy management, automation, and software all coming together. So people have been talking about this IT-OT integration, but I'm going to focus on what this IoT technology is doing in this energy space that I can talk about, right? So before I jump in to one slide on Schneider Electric, I kind of mentioned it in my introduction, but we are a 27 billion euro company, about 5% devoted to R&D, which is about 1.3 billion euro. We have 160,000 employees in more than 100 countries in the world. We're a truly global company, headquartered in Paris, France. Our CEO is based out of Hong Kong. I stay here. The executive committee is literally, it's a truly global company. And we all come together once a month to meet, and then we go back to wherever we live. So I'm fortunate that I get to work for a French company living in Palo Alto. The devices, all the energy management and automation things that Schneider makes, they make it in sort of low voltage and medium voltage areas, in the electrical distribution area. So in the little bit of primer in electrical engineering. So low voltage in the IT industry means sort of 1 volt, 2 volt. Low volt in this industry is 1000 volts. So anything going from 0 volts to 1000 volts is low voltage. And so we do a lot of low voltage products, which are breakers, switches that you have in buildings like this, etc., right? And that's low voltage. Then you have medium voltage, which is from 1 volts to 36,000 volts. That's medium voltage. And then more than that, 36,000 to about 1100 kilovolts is what is called high voltage. So people do transmission for lower energy sort of losses in the high voltage, but then you get to this, when you drive on 101 near Gilroy, you see this massive substation. That's where things come down into those medium voltage things, and after that it is distributed to your homes and so on. And so that's the technology. So there is medium voltage products that Schneider makes, low voltage products. We do not make high voltage products. But those products that we make, breakers, switches, panels, etc., are these sort of electrical distribution products. That's the hardware stuff. And then for each of these things, we also make the software automation stuff. So one of the end markets is our buildings market, right? So we are in a building. So there are sort of 3 categories of buildings. Residential buildings, like you and I will live in a building in whatever, in Palo Alto or here or Mountain View and so on, and we put a solar panel on top. That would be a residential building. A commercial building is a building like this, a typical building, right? Or a critical infrastructure building would be a building like an airport. So buildings is a very, very big area for us. And in fact, if you look at the energy consumption in the world, right, or total energy consumption, about 25% of it happens in the buildings area. So it's a very, very big area. But all of that is in the low voltage space, 0 to 1000 volts, right? But in that, we also have automation. So when you have a building like this, right, there is a air conditioner, there's a heating unit, etc., thermostat, and so on. All of these things are being controlled by an automation system called a building management system. So again, there are lots of BMS systems, but Schneider has a very big percentage of the market in the building management system. So buildings is one area. So residential, commercial, and critical infrastructure buildings. Again, the low voltage and automation. Next area is data centers. So these data centers from Amazon, Google, Microsoft, etc., right? There's a massive data centers that largest data centers are maybe 50 to 100 megawatts. I mean, when people are, how big is the data center? They don't talk about servers or gigaflops. They talk about, oh, I've got a 50 megawatt data center. I mean, it's literally how much energy is being consumed, or it's just crazy, right? You need almost a nuclear power plant to drive one of those big data centers. So that is a very, very big area for us, data centers. Third area is what is called our infrastructure. That's the medium voltage thing, our energy area. Those medium voltage transformers, switch gears, ring man units, all that kind of stuff. All the things that make that grid, that smart grid that I'm talking about, the microgrids and so on are all part of that infrastructure business, and 25% of our business is there. The last one is our industry business, which is asset-intensive industries like oil and gas, mining, metals, or whatever, right? So you have a process plant, right? You have Shell exploring oil in the North Sea, right? And you have to make sure that those things are generating or measuring the pressure, temperature, etc. And that is a control system, a real-time system that is doing all the wonderful things that you've learned in your electrical engineering controls classes, right? So that automation is that fourth area. That's about 27% of our business. So that in a nutshell is the whole energy management and automation industry. And again, like Schneider, ABB also plays in this space, Siemens plays in the place, Honeywell, Rockwell, etc. So this is the industry that is poised to get tremendous amount of innovation in the IoT area. So that's kind of the primer. So we have been working on IoT for some time, and a little bit of a sales pitch for Schneider. When I was talking about these automation devices, this thing that run the actual control systems, many years ago they used to be driven by very proprietary data buses called Profinet and Modbus and so on and so forth. Many years ago, in 1996, Schneider engineers had the vision that, well, maybe we should, instead of using those Profinet and those proprietary buses, let's use Ethernet IP as the way to communicate. And this was like a no. The rest of the industry said we should not do it. Some engineers said, no, this is the right thing, and I'm glad we did, because that particular invention has resulted in recognition in the Smithsonian and all kinds of awards, and that has become the standard in the IEC, etc., etc. So flash forward to 2016. April 1st, we had our Innovation Day in Paris, and we kind of announced a bunch of products. And all of these products, again, I will highlight these products, the Modicon EPAC product from our industry group, Altibar process from industry group, online services, all of these are sort of IoT-enabled stuff. So once these things, and I will talk about these things, like millions of points, assets, all the things that I'm talking about being IoT-enabled, you need an IoT platform to drive it, analytics to analyze the data on it. This is essentially the core of my presentation. So that's the kind. So now my talk is the Schneider innovation DNA. That's a pretty picture. So remember I mentioned that you have this sort of the 5 things that we talked about: safety, reliability, sustainability, connected, and efficiency. Right? Those are the core characteristics of any energy management system. So if you look at the base, right, we have worked on the safety area, right? So when, as I said, if you have electric short, you need to make sure that it is disconnected. So you need some breakers to disconnect AC breakers, DC breakers, etc. kind of technology. So we have had technology like multi-line, Acti9, compact, etc. So the latest thing that we are announcing this year, later on in fall, is the Master Pack, which is a very smart breaker and a panel, IoT enabled. So all of these things are now getting IoT enabled. So at the first level of making sure that you have a safe electrical system, that's safety. The next level, you need to make sure that your electrical things run even when there is a power failure. So you need an UPS, an uninterruptible power supply, to make sure things are running reliably. And you can have UPSs for smaller devices, all the way to have UPSs in data centers. And so our Symmetra system is our UPS in that area. And so that is addressing the issue of reliability. Again, those things are all now IoT enabled. Next level is our automation system. You have to make sure that your process automation things, oil and gas industry, etc., they all work in an automated manner. Machine structure, plant structure, these are our different automation tools. That gives you the characteristic of efficiency, again being IoT enabled. Then we have a lot of sort of interest these days on sort of sustainability, sort of solar, wind, etc. So we don't make the solar panels, we make the inverters for the solar panels, right? So all the control that goes into that. And the storage too. So solar without storage is of no use, right? Because when you have intermittent stuff, you need to store that thing. And so Schneider just announced a thing called the EcoBlade, which is the most cost-effective lithium-ion energy storage, more cost-effective than Tesla's thing that was just announced by Elon Musk. So, big deal in that sort of renewable area. And then finally, this connectivity that is going to tie the whole thing together. So, I started with the slide, life is on. We have sort of products in each of these areas, and each of these products are IoT enabled. That's sort of the innovation, IoT innovation at all levels. So, about 6 years ago, we announced a kind of an architecture vision called EcoStructure, which said this is how all the different devices that we have in our Schneider portfolio we can talk together. And so that was the overall architecture vision. It was just an architecture vision, not really a product or anything. But so applying that in our industry thing was sort of machine structure. Applying that to a process industry was plant structure. Applying that to data centers was infrastructure. Applying it to buildings was smart structure and so on. So we had a great vision about connectivity and operational efficiency and so on and so forth. What has changed in the last sort of 6 to 10 years is that we now have mobility with all the sort of iPhones and Samsung phones and so on that's out there, right? And the people that are the facility managers in these buildings, right? Or the person who is managing that oil and gas plant or that mining and metal things, those people now have mobile devices. And so you need to tie that device to all the stuff that is happening on your other end, right? All those circuit breakers and so on, the information of that needs to show up on your system. So that's what has changed. Mobility of the operators. Then cloud, everything is now going to the cloud, right? And then analytics. Now, one thing I need to kind of tell you in this world, right? People think that, oh, it says IoT enabled, I just put everything on the cloud. Can you do it? Yes, you can. Should you do it? Well, it depends, right? So just because you can doesn't mean you should. So in this area, it is, so people get, oh, I just have an IoT device, I just take this, connect to the cloud, oh, sure, oh, no big deal. I buy a Raspberry Pi, I do this, upload to Amazon Cloud, boom, done. Well, when you're working in the area of energy management and so, right, when you have an oil and gas plant, right, you don't want to do these things, upload to a cloud, and what happens if, I mean, you want to shut off a valve right then and there, right? So you need to have local control. So I'm going to talk about, show an architecture where, yes, we are going to do mobility cloud analytics, but in the context of a control system, you need to do certain things locally, what we call edge control, and some things on the cloud. So the application of IoT and cloud in the area of energy management automation needs to be really very well thought out, right? And so that's something that I did not fully understand before I joined this industry. It's very, very interesting because at the end, you have to be safe, right? Safety is a very, very important one of those 5 characteristics. So now I'm going to sort of double click and say, okay, so we had this EcoStructure, so we are essentially called, there's an EcoStructure cloud platform, right? There's a thing that I will mention. We just kept that same name, EcoStructure, but we are using this platform called ecostructure.io. So literally last month at IoT World conference, I gave a keynote, and that's where we first formally launched this IoT ecostructure.io platform. So I'm going to talk about what's in this EcoStructure in more detail. I mean, I just flashed this slide at IoT World, but I felt for this audience I need to go into a lot more detail. So let's focus on the EcoStructure at this different level. So as I said, people think that, oh, IoT is just products, connect these things up and upload to the cloud and do fancy analytics. In this world of energy management, you have this stack, which is this EcoStructure. But at the bottom of the stack is connected products, right? So IoT, what is IoT? It's the Internet of Things. You have to start with really, really good quality things. So at the core, when we have things like a Altivar sort of a drive is the circuitry that makes sure that your motor is running at that same constant speed, right? So you have a little drill, you take that drill and you put it in concrete, goes through and it's still going at 2000 RPM. How is it happening, right? Because the more torque is needed, is putting more juice into that thing, right? The drive. So those are sort of circuits for drives that will do all the motor control and so on. So in this industry, people have been making drives for a long time, but the context of it, these drives now are IoT enabled, and this drive is sitting inside a conveyor belt. That conveyor belt is trying to move things at a certain thing, so there's a conveyor belt, a fan or something else, right? A pump. That pump is being monitored by IoT, right? All this stuff about the performance and so on and so forth. And the feedback of that end user application is being taken in and being used to drive that Altivar process. This is the innovation that is happening in terms of the core connected product. Again, instead of the drive, we can say a tunnel. The master path tunnel that we just announced on April 1st is again the standard panel, but is now IoT enabled. And now sort of facility managers can have access to all the information and do amazing things with it. But so in the IoT world, you have to start with really good things at the bottom, right? They have to be safe and reliable and all that kind of stuff. And then the next thing what I was talking about is the edge control. You cannot just take this and upload to the cloud, because imagine you have a building management system, and the system, if there's a fire, that door needs to be closed automatically, right? Now, if you have a building management system and that little AT&T is not quite working right now here, right? You cannot say, oh my God, I didn't have connectivity. So, in the mission critical applications, which is typical of process control and so on, right? You need to have control, localized control at the edge, right? So people are talking about sort of in the IT industry, edge computing, fog computing, etc., right? And some of that is needed by where the compute happens and trying to do. This is a necessary condition. You cannot just put everything on the cloud. So that's the edge control part. And so towards that, we are showing some examples of some of our process control systems, right? The smart structure, the machine structure, etc., all those automation tools, structureware, and so on. Then on top of it, so you have the EcoStruxure Cloud. This is the actual cloud platform, and I will go into a little more detail later on about exactly what we use with Microsoft Azure and so on. Then you have applications and analytics, and you can do very interesting analytics. I will show some examples later on about doing all the analytics, and that analytics shows up on the iPad of an operator in a plant. So essentially you can make really good decisions. So it's a visualization analytics shown on that mobile device, the iPhone or iPad or tablets, right? And so those are the apps and analytics. And then, so this is showing an example of a Schneider customer in a public works department where he's saying this ability for engineers and operators to see what is called augmented operators. You point a thing, right, that iPad on a machine, and through that augmented reality, you can see amazing things about what is behind the machine and so on and so forth, all enabled through IoT. So that's a real customer case. Another customer case of using IoT to drive actual value is Duke Energy. They are one of the largest energy utilities in the southern part of US. So they have lots and lots of plants, and so in those plants, right, you have lots of assets. These are very, very expensive assets, and these assets need to be maintained, right? It's like your car, you need to do your oil change for your car every sort of 5,000 miles, right? And so using the world of IoT, right, you can do asset management, you can do predictive analytics and say, well, so normally you send your car every 5,000 miles for an oil change. But if your engine starts giving trouble, you probably should do that oil change maybe at 4,000 miles, so you can delay it to 6,000 miles. That concept of predictive analytics is sort of applied in this area. So what Duke Energy did is, they have a bunch of these very, very expensive machines, and are predictive, and there's a certain temperature that the different blades in a gas turbine are supposed to have. This predictive analytics flagged this problem. Hey, you're thinking there's an anomaly here. And they said, no, we have done all our checking, no problem. No. And finally, the software was right, the humans were wrong. And they were able to save, in this particular case, about $500,000. overall cost per year savings to Duke Energy, $10 million. So IoT, real economic value being generated because of the site. So those are some apps and analytics. And finally, services. And this is kind of so all the entrepreneurs in the audience, right, who are looking for sort of, what am I going to do with IoT? The real value is the data that you collect from these devices, right? And the services that you then create. So this is back to my story when I did my World Economic Forum talk in Davos, right? It is about, so what services have I enabled to it, right? So the low-hanging fruit in IoT, everybody does it, is remote service, right? I sell you a transformer. In the past, when that transformer failed, you call me up. That was there. Now, when the transformer fails, it calls home, right? So essentially, you know before, I mean, so literally, Schneider knows that your home does not have power before you realize it, right? So that's the remote services. That's for the low-hanging fruit. Everybody does it in whatever industry, right? From airlines to this to whatever. Right? So remote monitoring, very asset performance management. So moving from just that thing has died to now it is, I'm trying to predict that it's about to die. This is a really interesting thing. In fact, and I'm sure there are analytics people from TIPCO and so on probably are working on this topic. There are general analytics that you can run, and then there's sort of domain-specific analytics. This is the real opportunity, if there are entrepreneurs in this audience, is to, I mean, you can't just work on an IoT platform, IoT analytics, right? Pick a vertical, doesn't matter, healthcare, energy, this, etc., engine control, and make that IoT enabled, and now build a real interesting solution, right? So that you know that that Tesla engine, right, which is before we fall sick, we kind of, our fever goes up, right? So we give signals about the fact that it's about to fail, right? So that analytics, this asset performance management is huge opportunity. And then now we are actually looking at sort of in our Schneider Think on a bunch of what is called digital services. We are doing all kinds of evaluation of so what kind of services can I create? And this is the other thing that for the entrepreneurs in the audience is an opportunity, right? So look at the iOS platform, right? So the platform is a sort of technology, you can access certain data through APIs, but Apple does not write those millions of apps. Somebody else out there, right? Those people in a garage are creating the apps, and Apple gets 30% of the revenue. In the IoT world, right? All these connected products, they're generating data. Just huge amounts of data being generated, right? So that data is sitting on a cloud, on a platform. Imagine how you could unleash the power of these millions of thinkers, entrepreneurs, who will think about the opportunities on this. So this is kind of the vision that I think GE is pushing in terms of Predix, we are doing in terms of EcoStruxure.io, etc., right? So that, my message is a real end-to-end system, right? Be it for jet engines or whatever, those services are where the real value is. And so, an example of a service is sort of energy performance services, and I will now go a little faster because there's more content to cover. So imagine you have some customer assets, some electrical assets, right? You're connecting your lighting, your power, your HVAC, etc., right? All of those are connected. Then those things are generating data. This is the point I was trying to make, right? You consolidate and analyze that energy data. You make that data available. And then you can do all kinds of, just you can imagine, what can I do, right? What kind of value can I provide? I can have create an analytics tool to build energy patterns and saving. Hey, if you did this, you could save more energy. You could do this, you can do whatever, right? So connecting is only sort of step one, right? Once you collect all this data, massive amounts of data, you build, you unleash a whole bunch of digital services on top of it. That's sort of the journey that Schneider is on. So there's examples of other services that we're working on for facility insights and services, and for a building manager, what we are doing in terms of collecting all the data of this TIPCO building, for example, watching all the stuff daily, hourly, etc., collecting all the data, detecting abnormal consumption, and based on that, the facility manager on the iPhone will say, so that's a service that we have created, right? Facility Insight, Facility Hero. And these are the kinds of possibilities. Essentially, the problem that I talked about, right? This 1.5 times energy consumption, reduce these things. All that data that is being collected can be used to drive much better what is called demand response in this whole grid world. So now let me double click on sort of the actual cloud, the connectivity technology. So ecosstructure.io, again, this is the cloud platform that I mentioned in the IoT World Conference. It's actually a platform. There's sort of three things that we have working on. So the device intelligent platform, those connected products that I kind of talked about, those devices themselves are IoT enabled, but there's some local intelligence that we are putting into them. So those devices, that's the edge control, the local intelligence, some of them. So I will go into a little more detail in the next slide, but there's that as one platform. But sitting on top of it is sort of a smart operations platform which drives business, running all the plant operations like all the oil and gas plants in mining, metals, etc., and the digital services platform which is creating all the new services like Facility Insight and so on and so forth. So if you look at the IoT world, right, so there's 4 steps that you have to do. You have to connect your devices, your smart panel, your jet engine, whatever, etc., valves, PLCs, and so on. Then you have to collect the data. So you have to connect, then you have to connect the data to whatever, right, through Wi-Fi, 3G, 4G, Bluetooth, Zigbee, etc., right? Then you analyze the data, and then based on that, you sort of close the loop and try to drive better performance, right? You're driving more energy efficiency, etc. So this is actually, so I'll go to that slide later on. So double clicking on that, so each of those platforms, they can be broken up, right, into this connect, collect, analyze, close phase. So at that device level, we are talking about sort of connecting, we're doing discovery, onboarding, how do you connect this device? So we are essentially at my CTO level, this whole organization sits in my organization. So we are providing the platform bricks for the rest of the company, the 160,000 employees to use. Okay, you want to connect anything up? This is how you connect up, right? In terms of whether you want to Bluetooth, Zigbee, this, etc., and the basic core embedded processors, what processor should you use the ARM processor, that processor, all of that, and the sort of local analytics, the local machine learning analytics is part of that platform. So that goes to all the users, all the different 4 businesses at Schneider as a package thing, right? If you want this, you get that. Then the next level is the smart operations platform, which is all the businesses that you're running, all the sort of the process automation, oil and gas plants, mining, metals, etc. And then finally the digital services, finally on top of it, the Facility Insight kind of services. So we don't do everything ourselves, right? So we practice open innovation, everything. When you have experts in the community, in the ecosystem who are already doing good stuff, you should really leverage that. So we leverage our partnerships with both ARM and Intel in terms of sort of processor technologies and so on and so forth, and with Cisco for our device intelligence platform. For our smart operation, DSP, etc., again, we use a lot of partnership with Microsoft, Cortana Analytics, and so on. So again, our cloud platform is running on Microsoft Azure. We've done Amazon, there's that, Google, IBM. Just pick one. So we have picked the Microsoft Azure, that whole stack. And so I think there's some questions in the audience. Do you use Hadoop? Yes. Spark? Yes. So all the open source stuff that everybody uses, we have. So the point I'm trying to make is anybody can create an IoT platform. That thing is sort of the technology stakes is not a big deal, right? Oh, I can announce it, EcoStructure, right? That is not the point. The point is using this kind of a platform to build this thing, right? That energy management automation in that industry, and can you actually provide that? This is where the so I want to kind of share some insights. We were having a lot of debate internally. Oh, this is connected, that's not. So what's being measured and connected and so on. So we came up with a good way to measure connectivity. So there are sort of three things. So concept one is connectable assets, right? So we sell, say, a protection relay. That's one of our medium voltage products, right? They do this medium voltage stuff, right? So when bad things happen, disconnects happen, right? So that thing is manufactured, sold through an Ethernet connectivity. So that thing is connectable. Whether it's connected or not, we don't know, right? So it is shipped out as a connectable. So just because I ship a whole bunch of sort of transformers that are connectable, that does not mean they're IoT, right? Unless it is connected, we should not count it, right? So there is the connectable assets. Second thing, these are connected but are not managed. So yeah, you have connected it, but you're actually not doing anything with it. So that also doesn't count. So the thing that really counts is the connected assets that you are actually managing. So I have a transformer, right? I have a breaker. I'm actually monitoring that breaker on off, etc., right? And it's about to fail. And based on that, I have a maintenance contract with the customer saying that if that thing fails or if it's about to fail, I will give you a call, right? So that's the asset under management. We at Schneider are tracking how many of these assets are actually under management. And we have a goal. And then so we started with 0. And we made progress. We connected 10,000, 50,000, 100,000. This, about last month, we crossed the 1 million number. That is a very big number. To just compare, is there anybody here from GE in the audience? So GE obviously has a very fantastic platform called GE Predicts platform. I know Bill Rue, I have talked to him. The assets under management on the Predicts platform, I have heard, is about 350,000. So a million is actually a lot. Again, you have to, now they are dealing with, when they connect up this one jet engine. So that's one big thing. One jet engine is much bigger than a tiny breaker. But I'm just saying, if you are looking at the IoT connectivity, it is the number of things that you're actually connecting and managing. And we have a 3-year journey to connect up to, we have identified 10 million assets. So we are on a journey, starting as I said, 10,000, 20,000, 50,000 million. We are crossed a million. We will be at around 1.3 million by this end of this year. But we have a moonshot goal of about 10 million. So just imagine, so just these are Schneider assets, right? And so then there are other assets that other people are connecting and so on and so forth. That is generating a lot of data. So all of this data from this 1.3 million to 10 million will be available on this platform, right? Oops. And just imagine what you can do in terms of services with it. So the journey that we are in is, oh, Honeywell has an IoT platform, Bosch has an IoT platform, anybody can have an IoT. There are 150 IoT platforms out there. It is about what you do with that platform, right? What are you actually solving the ultimate customer problems in terms of energy efficiency and CO2 emissions and so on and so forth. That's sort of the end statement. So, so applying IoT in these different areas, as I said, our end markets are homes, buildings, data centers, industries, and sort of infrastructure, the grid. So this year we did a new survey of what is called IoT predictions in the future. And we surveyed about 2,500 customers. And we asked them, what do you see in the next 3 to 5 years? So this was published as a report, and again, I don't want to go through the whole detail, but it's available on our Schneider.com/IoT page. You can download the report. But the really interesting things that our customers, 2,500 customers, have said is that 2/3 of the organizations that we interviewed have said that they are, so IoT is here today. So 2/3 of them are implementing IoT solutions via mobile applications this year itself. So IoT is completely here today and so on. And then there are some sort of different areas of where there are different applications of IoT. So the first one is that the next wave of digital transformation is here. All of us, right? We are now so hooked onto our iPhones, iPads, tablets, and so on and so forth. The world is getting digitized, etc. So this digital transformation, everybody's going to connect everything together, right? So that's the first one. The second one is that all these things that you're connecting, right? Data on this local, this train or this or building and whatever, etc. Right? From the data you're collecting, you are going to take this data into insights. So insightful data. Site to cloud confidence. So initially people were kind of scared of using IoT, but with this, so other people are also thinking about this, right? Do things at the edge control, so that at least when bad things happen, if you're disconnected, you have some automation to run locally. So, and then the rest of the stuff you do on the cloud. So that kind of a site to cloud confidence is coming in this industry. There's a whole bunch of innovations that is happening in this IoT industry. Ultimately, the prediction that is that our surveyors mentioned is that IoT. What's the end game of IoT? IoT will result in a better planet, which is about reducing energy consumption, reducing CO2 emissions, and so on. Which brings me to my life is on, right? So the world has sort of two challenges: delivering energy in a sustainable, connectable manner, right? And so that energy is a basic human right. 1 billion people on the planet do not have access to energy. Other billion have intermittent. We need to make sure that everybody has access to energy. And as the energy consumption grows, with electric energy becoming 80% more, right? That electric energy consumption is unsustainable. So you need to have real innovations. And these innovations will be enabled by the world of IoT. So it's not just IoT for the sake of IoT. IoT applied in this area will have tremendous applications so that society benefits, so that life is on, so that energy is delivered everywhere, to everyone at every moment. Thank you.
Thank you, Prith. So we have some time for Q&A, and so there are people with mics on both sides. I'll give you mine. Just kind of.
So you can just introduce yourself before.
I'm Srini Iyer. Thanks for the presentation. Wonderful. One question I had about control at the edge. What about like compute? Like, do you kind of compress the data? Do you kind of do some level of aggregation so as to kind of prevent this deluge of data hitting the cloud? Or do you want the entire stream uploaded to the cloud?
No, you do local. That's why when I talked about that device intelligence platform, we do local compute. And so when we talked about the partnerships with Intel and ARM, we have processors there, different levels. So our approach is for our IoT thing, right? We have sort of IoT sort of devising, sort of small, medium, large. So depending on the thing, right? If the thing that you're connecting is this massive transformer, then you probably need a much bigger thing. So depending on the thing that you're connecting and the amount of data being generated, you will do a small, medium, large processing capability and the appropriate analytics at the local level at that edge, and then send the remaining summary data to the cloud.
So in a way, we're kind of going back to, at least in computing terms, like the thick client and server model. So doesn't it have all of those problems with supporting thick clients in terms of pushing updates to these devices and all of that kind of stuff? How have you guys surmounted those challenges?
So in our area, so because we work in the energy management automation area, the automation devices, right? These things have the valves and programmable logic, PLCs and so on and so forth. They require those updates and services anyway. So it is not any added thing. But you raise a very important topic, which is topic of another talk, which is about this. Can you use some general software techniques as has been used in the networking area, like software-defined networking? Can those be used here? And we are kind of cooking some concept in the area of what we call software-defined automation that will go into those areas. And then once it is more generic, you can actually update things in a more more easier. It's a great question. Thank you.
We have a question over here.
Hi, Prith. This is Sanjeev Srivastava. I'm with Persistent Systems. So you laid out a very good vision for the next 50 years or so of how much control you need on the grid. But Schneider's been around for a few years, and you have a big installed base of switches and such. What's your vision of how you're going to retrofit your installed base, replace? How are you going to manage the existing infrastructure?
That's a great question. In fact, it was asked of me at the IoT World Forum in Dubai. Absolutely correct. This industry, the energy industry, moves slower in terms of upgrades than the IT industry. In the IT industry, I upgrade my phone every 2 years or every 18 months and so on, so you throw it up and so on. So in the IT industry, you can do all kinds of stuff and say, okay, boom, things have happened. In the energy industry, some of these transformers are there for 30 years, right? So, and you cannot just go and change things. So it's one thing for greenfield and another thing for brownfield, which is your question. So the way we are approaching this, and we have given it an interesting name, we have given it a name of what is called, instead of a revolution, we are talking of an evolutionary revolution. Meaning that you just don't do a complete rip up and replace of all the transformers, right? So you take a set of assets that a customer has, and selectively you will go in and retrofit that with what is, again, I did not go into details, but the concept of secondary sensing. People in this industry, right, so they'll put some sensors on top of it and start connecting that up. And so you have a whole bunch of stuff, but only 10% of those will be brand new stuff, another 30% will be these sort of secondary sensing devices. And then over time, over 10 years, you will upgrade all of it. But the good thing in this industry is that our customers, they're sort of, once we have a deal with ExxonMobil, we have a $100 million deal with ExxonMobil, and we are just in there for the long haul, right? So we have a contract, we'll keep on upgrading 10% of their devices every year. It's like, so that's how we do it, right? We are partners with big companies in for the long haul, and so we are in this journey of what we call evolutionary revolution. And the analogy I would give is, I'm sure you know about the story of a frog, that if you put it in a hot water, immediately jumps out. Versus you put a frog in a cold water and it gradually raises the temperature, it doesn't realize it's hot and it dies. So we are doing the frog, putting it in cold water and gradually raising temperature. Our customers will not know that there was a revolution, but oh my God, after 10 years, the frog did not die, we just got the business.
I'm Sanjay, Accenture. I had a question regarding how are you changing your management of your devices? Are you changing, I'm assuming all your devices had instrumentation built in already into them. So it's a little bit of a greenfield and brownfield category. So have you changed that, and what technologies are you using, SCADA or just plain IoT, or what are you doing to manage these devices?
So that part is the same. So it's the same SCADA device. So those control things are the same. But now, to his point, right, how do you do the upgrade? You're all essentially asking the same question, very valid points. But our approach is literally, there's an approach for brownfield and approach for greenfield. For brand new things, we'll do the latest master pack, all the things that I'm talking about, right? But then there is this, we have master packs which are not IoT enabled. And for them, we are providing customers the option, now you can put this extra secondary sensing device, now we'll start connecting stuff. And once people get hooked onto the services on that extra stuff, oh, they want more of it, and then they'll gradually, so over a period of 3-4 years.
So in your world of IoT, you are mixing IoT and SCADA into your sort of use case, if you will.
Yes.
That's how your world is different.
That's true.
Right. One more question over here.
Alec Abrams, UC Berkeley. This is maybe talking half a level down technically, but what's helpful to guide architects is a programming model of the system of the systems that they have to work with. So, from Schneider's point of view, surveying the multiplicity of IoT platforms, Do you see programming models being developed that are IoT specific, or is it just going to be the usual web mishmash of JavaScript, Node.js, C++, C Sharp, a little bit of C down at the bottom, that sort of thing?
That unfortunately is the reality. We are not an IT company. We are trying to leverage what is the best things coming out from the IT world. And so we are embracing all the latest stuff coming out of Berkeley, Spark, etc. Right? All the things coming out of but the Hadoop world, etc., etc. I mean, yeah, we are taking the latest, greatest, best stuff out there and incorporating it. The world does it need it? Absolutely, but is it there yet? Not yet. So, absolutely great research project for UC Berkeley. By the way, we have started an open innovation program with startups, so that all the R&D projects that we have, we are trying to make sure that if there's a startup in Silicon Valley, then we're going to work with them, and open innovation with universities. So we should absolutely talk to Berkeley.
I can tell one thing. Facebook has one programming language which encompasses the requirement. I can tell you skills. It actually does fantastic thing at communication and comprehension. It has the language.
Another thing people are doing is starting to build sort of toy projects with flow definition languages like Node-RED, but they're not quite enterprise ready yet. So there is room for sort of hardening tools like Node-RED.
And again, my technologies are following. I've got a big IoT team. They're all following all those technologies, but it is a mishmash today, as you pointed out.
Hello, Prith. Raisika Sensitab, a very illuminating presentation. So you talked about a goal of 1 million devices or 10
Not
million.
goal, we have
10
achieved.
million
Yeah,
devices.
goal of 10 million.
Right. I was curious how you will scale the need to monitor those devices. So are any humans involved today? Because I heard in China they have 20 million cameras, but they have 1.5 million people actually looking at those screens. So how will you use data? So are we creating a problem for ourselves?
Actually, this is a great question. I mean, so the IoT white paper that we presented at Davos kind of talked about sort of the human-computer kind of a thing, right? And essentially, these are coming together. I mean, there's a lot of machine learning analytics. When you look at a picture, you say, hey, there's a frog in the picture, a girl in the picture, and so on. So you can automate it, but so the easiest 90-95% you automate, but ultimately the last 5% or 10% you have to do the human. So absolutely, but maybe this is where the jobs are going to be created in the next presidential economy. I think you're right, but I think a lot of it will be automated. It's not like we are creating all this data, all the analytics has to be done by humans. The simplest things, which is the 90-95% will be done through this automated, the machine learning stuff, etc., etc. And which is now another topic I want to talk about. I know that there's Andrew in the audience here from NVIDIA, right? So they are working with sort of using their GPUs, right? So machine learning, AI has been around for the last 20 years. What's new about machine learning is today, the cost of compute and the cost of storage has come to a certain point that you could do things in real time that you could not imagine 10, 15 years ago. And GPUs are one form of that high compute capacity, right? Which is that problem, that machine learning problem is, it looks like I'm a salesperson for NVIDIA, but I actually believe it. So we are seriously looking at using NVIDIA GPUs in our stuff. I mean, I've got my team talking to them. So machine learning at Google uses NVIDIA GPUs, right? So I think many of the technologies in this area are coming to a point where people, oh yeah, it's machine learning, it's AI, it's known. Today, it is actually possible because the cost has come down.
Here.
Mathieu Roplin, Airbus Group. I happen to grow up in Grenoble, so I know a bit Schneider, and for me it used to be really a hardware company, actually. Schneider, Banerjee, all that. And all those things, there's a lot of software. Are you going to do all that in-house? Are you outsourcing? And what does it mean for Schneider?
So, another great question, and this is, Schneider is actually going through a transformation, right? They are trying to evolve from a hardware company into a combined hardware software company. And so, of course, they are bringing in a lot of software talent in-house. And the reason I am here is I am trying to leverage all the partnerships with startups and so on, and to bring some of the technologies from the startup companies in Silicon Valley, and to hire some talent here. So in our North American headquarters in Boston, all the developers, almost all of the engineers are software people. So we are recruiting a lot of software people into Schneider to complement the very smart engineers that are there in Grenoble. Our R&D sites are now, we have 5 major R&D hubs. Grenoble is still the king, master, but we have R&D sites in Boston, in Shanghai, Bangalore, and we're just now opening up a Silicon Valley site, taking advantage of my location.
Sunil Valig, I had a question about the 3 type of assets you had: unconnected, connectable but not managed, etc. Are they connectable but not managed today? But is your vision that they eventually will be? It's just your priority of working on the low-hanging fruit first?
And this is why I wanted to, when I said 1 million, there were 1 million in the right-hand side. I could cheat and say I have 10 million. I have 100 million, right? So that connectivity, connectable, yeah, I could connect, doesn't matter. Have you connected today? And do you have a service? Basically, the connectable is on the right-hand side is, are you managing those assets? Just being connected, right? But you're not doing anything with it, right? So I'm connected, but if that does not, that ET phone song does not happen, then does not count, right? So when we are saying it's a million of the assets, connected assets under management. That's a really high bar.
Hi, Ruchir Tiwari. I'm a security consultant and a mobile software developer. Ruchir Tiwari, security consultant and ex-mobile, current mobile developer as well. A question about, you mentioned that you want to develop an iOS-like platform that a lot of people can develop apps, for structure. Now, the mobile ecosystem, people develop apps using public APIs for context that they're familiar with. Now, here you're trying to develop apps for industrial use cases, which an average, dev shop is not familiar with, and even the access to data, it's an unknown way to get that. So what are you doing to democratize access to this rich industrial data that people can then develop apps on and develop the intuition to get the insights that you need?
Great question. This is where we are on a journey. First of all, we are in the process of publishing our APIs, right? So first, it was a big debate within Schneider. In the last 9 months, I've been arguing that we should open it up, do the open API, etc. That debate is now over. We are going to open it up, and so that we enable this thing, because there is no way, just like in iOS, those million apps were not created by Apple. I strongly believe that we cannot do it ourselves. Right? So we need, but we also believe that if you have no apps, then the developers would not know what to do with this data, right? So the first 100 or 200 or 500 apps will be done by Schneider. And then we say, hey, this is how we did it, etc. So there is a little bit of education thing, and we should probably talk to Berkeley and Stanford. So like, how do you educate the next generation of people to do this kind of stuff? But we will publish APIs, and that data on our platform, right, will be available, because then you will be able to access that data and do interesting things. Let me give you an example, right? And this is a case I have used within Schneider. So this building has a solar panel. Let's assume it has a solar panel, right? Now, it's generating power during the daytime. Now, let's say this is my home. So I have solar panel in my home, right? And it's generating a lot of power. Now, with all the net metering, if it is connected to the grid, if I don't have storage, then basically with net metering, when I have extra power that I'm not consuming, I sell power to PG&E. In the evening, when there is no solar, I buy power from PG&E. Hopefully, the net thing kind of works out because I sell things at the same rate, etc. Right? Now with solar and storage, I have the choice of, I can now store that energy instead of selling it to PG&E, I can choose to store it on my storage, my EcoGrid storage. Then I have a Tesla car. Actually I don't, but let's imagine for a day I have a Tesla car. So that Tesla car needs to be charged. I come in and charge it in the evening. I'm not going to charge it when the solar power panel is there, I mean, because I work during the daytime, right? So then the choice is, how do I charge? Do I charge that Tesla car through paying PG&E through net metering, or do I store that energy in my storage? I just give you a ridiculous example, but imagine that EV charger, actually the EV charger, we have EV chargers for cars, right? That is IoT enabled. That data is there, right? My car battery is IoT enabled. So I know I am 60% charged in my Tesla battery. I will come home, I need to do the 40%. Now I do a quick math, right? During the daytime, I know that, hey, my Tesla car will need to be charged tonight, but I did not do it yesterday. So yesterday, I sold my power to PG and I made a lot of money. Today, I will not sell it, I will store it in my, now I have got connectivity in my EcoBlade, connectivity in a solar panel, my EcoCharger. Just imagine if I have the data on all of these things, you can create now a service which is this very interesting optimization. Just can imagine. So once you have the data on all these multiple things, it does system, amazing things can happen. That's the ecosystem I'm trying to drive. I just gave an example, but you can imagine a lot more.
We have question here.
My name is Matthias, I'm with Asian Link, I'm a hardware developer. And my question would be, how is Schneider approaching the question of how you secure the endpoint and how you secure the data in transit?
Each question is getting better and better, right? Just to give sort of 5, 6, 7, 10. Cyber security, I mean, on that chart, I did not go into because I tried to keep it in a 1-hour presentation. I really wanted to have the questions. So on that chart, there was those connected products, edge control, apps and services. On this vertical thing one was on-premise and cloud, and the other vertical which I just did not talk about was cybersecurity. Very, very important. IoT security is needed in the IT world, but if somebody hacks into my Facebook account, big deal. They can look at my pictures and post whatever. But if somebody hacks into the nuclear power plant IoT system, that is a very, very big deal, right? So all these companies are taking cybersecurity like crazy. There are technologies that we are working on, you may or may not know, like data diodes, right? So there is, just by the way, so there's companies like Owl and Waterfall who are creating these things called data diodes that allow data to only go one direction. So a hacker can hack in, they can read the data, but if they cannot write it, they cannot shut down the reactor. So they can read the ratings of microstructure. So there are all kinds of things that are being worked on. We have a whole cybersecurity group, cybersecurity across. So that's why it's a vertical in my IoT platform.
Hi, this is Sarah Peach from Siemens. You mentioned earlier in your talk that the applications are where the real value is created. But in an industrial setting, to create the applications, you really have to have a very good understanding of the customer's process and the customer's workflow. So how are you going to acquire that at Schneider, or how are you going to share that with this army of developers who are going to be on your platform?
That's a very good question, and again, Siemens has yet another of those analytics, the Schneider platform. So GE has Predix, Schneider, we have EcoStruxure. So all of us are in the journey together. It's a great question, and so we are having those discussions as to, again, that data, who owns that data, right? So this data of this TIPCO building, right, is it owned by Schneider because all those things are Schneider things, or is it owned by TIPCO because TIPCO has it, right? So there are these data ownership things, etc., that we are also exploring. So not all this data on the platform may be available to developers. I agree. I gave a very simplistic answer, but we are definitely working on making our APIs all public so people can do it. And if there is data that they cannot do, then that particular app will not leverage that data. I mean, you don't have to have an app that accesses all the data all the time, right? So it will be a limited app on whatever, some capabilities, right? So this example that I talked about, the solar panel and the storage, I don't have access to Tesla stuff, so I will not do that EV charging application, but I can do other things with the net metering. That would be my approach. But that's a great question.
Great. I think we're all set. So first,